Hello guys, my name is Aditya and today we are back with the second video of data visualization using Seaborn library in Python. Okay, so yesterday we have covered this line plot and bar plot, and today we'll be covering scatter plot, LM plot, which is regression line plus scatter plot. Okay, and we'll also cover one more thing, that is REG plot, regression plot. Okay, and we'll be covering it towards the end, which I've not written here, due to some obvious reasons which I'll be telling it to you towards the end. So wait till the end, I'm sure you will learn something. Okay, so this is what we have, this is just a glimpse of what we have done yesterday. Okay, we have seen how bar plot works and how this line plot works. If you have not watched the previous video, you can always check the playlist and you can watch the previous video. Okay, so today we'll be covering scatter plot, LM plot and REG plot. Okay, so REG plot is not written here, so let me just import pandas and seaborn, and I'll be importing this dataset, iris dataset. The description of this the link of this dataset is given in the description below. You can go there and download. Okay, and work along with me. So I'll not be doing this, I'll not be running this section because I don't want to drop this species column. I want the species column for this scatter plot and LM plot. Okay, so how can we draw a scatter plot? Just code for scatter plot is sns dot scatter plot, and then we have to give something towards the x-axis. Let us say data dot sepal length, and towards the y-axis data dot petal length. Okay, if we just simply do this, it should run, but this is not data, this is dataset. So see, this is the scatter plot between sepal length and petal length. Okay, this is the scatter plot. That means, suppose let's say for 6, at this point it is nearly 4, right? For a sepal length of 6 it is nearly 4. It may be sometimes more than 4, but I'm just talking about this point. This is 6 comma 4. Okay, the coordinate of this point. So it is a sepal length versus petal length plot, scatter plot. So what can we see here? See, first thing we can see that how the data is spread. Okay, if we just plot two columns, these two are columns. Okay, columns of this data set. So if we plot these two columns, we can see how the data is spread. Okay, so uh, towards the beginning, I mean towards the lower petal length. Okay, the data is spread almost horizontally, then it goes diagonally. Okay, so this is how we can visualize this spread. So the regression line would be somewhere like this. Okay, regression line would be somewhere like this. That means it is uh, an increasing relation. Okay, if the sepal length increases, petal length also increases. Okay, so this is how we can see the spread. It shows the relation between two continuous variables. Okay, between these two continuous variables, and it can also be color coded with a third categorical variable. So in order to color code with a third categorical variable, that's why we have not deleted the species column. The species column is a categorical variable. I hope you understand the difference between a continuous variable and a categorical variable. Okay, the range of continuous variable is infinite. Uh, it is a real number. Okay, the range is infinite. Real numbers are continuous variables, whereas categorical variables are discrete. It has a finite elements inside it. Okay, suppose like the dates in a month, it might be 30 or maybe 31 or somewhat some other count in February. Okay, and days in a week, Monday to Sunday, right? These are all categorical variables. So the species column had Iris setosa, Iris virginica, and Iris versicolor. So these are the only three values, hence it is a categorical variable. Okay, So in order to separate this plot with a categorical variable, we write hue and we give data dot species dataset dataset. Okay, so see, now we have now we can see the relation between two continuous variables based on a third categorical variable, okay, using different color codes. The color codes are given here. This is called the legend, okay. This section is called the legend. Now we can clearly see that for less than 2 petal length, okay, the less than or equal to 2 petal length, this the sepal length does not grow, I mean does not grow. Yes, it is nearly constant for iris setosa, okay. And if the petal length is below 2, then we can clearly say that it is iris setosa. If the petal length is between something like just an example, okay, something between 5 to more than 2 and less than 3, then it is iris versicolor, and if it is greater than 5, then it can be said as iris virginica, okay. So these are just simple observations, not much clear observations, okay. So this is how we use a scatter plot. Now what if we want to draw a regression line along with it, okay, a line that shows that yes, such kind of relation holds, okay. Then what we use is a LM plot to get the regression line along with scatter plots. So let us just do the same thing, okay, and let me write here LM plot. The syntax for LM plot is we cannot use such kind of things, okay. We have to give the column names here in this way, and we have to give the column names here as well in this way, and again same thing for the hue. This is also a column, so we have to give it this way. And finally we need to write data is data set. The data from which these columns should be taken is data set. This is just the syntax of LM plot. We cannot do anything with it, okay. So this is how we can get a regression line, okay. So such kind of, see, it is increasing, it is increasing, it is not much increasing, it is towards nearly parallel to the x-axis, okay. So this is when the petal length, it's not like if the sepal length increases, the petal length also increases, but in these two cases, if the sepal length increases, then petal length also increases, okay. So these kind of things can be seen using LM plot if you want to get a regression line. See these the small uh, the light green colors you can see here, right? This is the variance, okay. I mean this is, yes, this is the standard deviation from this line. If even if the data deviates this much, we can consider it fine, okay. So this is how we can use LM plots. See, there can be multiple regression lines with respect to hue, right? See, if we don't if we just remove this thing, okay, I'll just copy this code and let me just write it here. If I don't give the hue, then this all will be a single color and we will get a single regression line, right? So this is our single regression line, okay. So we don't have multiple regression lines based on the classes, okay, based on whatever hue we are giving. So we have a single regression line. Now this regression plot is also a subset of LM plot, okay, but the only difference is in LM plot we can give something like a hue, okay, and here also we can give a hue, right, in scatter plot. But in regression plot, REG plot, we cannot give a hue, okay. It can we cannot color code based on different hues, okay. It will just be seen this way, okay. So if I just copy this thing and paste it here, and if I just write regression plot here, REG, okay, then it gives the exact same output, just the scaling is different. See, nothing much different, just the scaling is different. Here the scale is small and here the scale is large. Otherwise these two graphs are completely same. Okay, so that is why if we know about lm plot, we can already we can do everything that can be done by a regression plot. Hence I have not written there above that we'll be studying regression plot explicitly, though we covered it. But if we already know about lm plot, then we do not need to know about regression plot. Okay, so this was all for today. I hope you got whatever I was trying to explain. If you didn't get, please comment down below. Let me see where you're facing problems so that I'll be able to clear it up. Okay, and see, these all the plots that we have done till now works completely on continuous variables. They do not work on categorical variables. Okay, this is also continuous, this is also continuous. The hue may be categorical, but we are not working mainly on the hue. We are plotting this versus this, right? X versus y, and both the x and y should be a continuous variable. Here also same case in lm plot, and in regression plot also the same case. We work with continuous variables. In scatter plot, bar plot, and line plot, we completely work with categorical variables only. In There are also plots for continuous variables which we'll be exploring later, like swarm plot is for continuous variable, right? And we'll be seeing how these plots work. So I hope you understood, uh, and thank you for watching the video. If you actually like the video, hit the like and the subscribe button. This will be enough for today. So thank you very much. Also share it with your friends and have a great day ahead. Bye bye.